There is one last mechanism, and it's a minor one. It's no big deal, and it's very easy to recognize. It's called E1cB, and the E1cB happens when there is a carbonyl, 2 carbons from the halide. So if you see a compound with a carbonyl in it doing an elimination reaction, you can be pretty sure that it's going to go through the E1cB mechanism. What does E1cB mean? It means E1, it's unimolecular. The compound does this on its own without any base in the transition state. And what happens is you form a conjugate base, and through that conjugate base, you have elimination occur. The base can, right here, a very fast reaction is that the base can remove a proton adjacent to a carbonyl. When it removes a proton, it gives an anion that is then resonance stabilized. This sticks around a lot. This is not the rate limiting step. The rate limiting step is when it goes from here to here and forming the alkene, that it takes time for the halide to be eliminated. This is not, there's not going to be a big emphasis on this reaction. It's really easy to recognize because you're going to have a base and a carbonyl and a halogen 2 carbons away from the carbonyl. So this is a summary of all the reactions that we've seen in this chapter. The alkyl halides will undergo a number of different reactions, and all these reactions are in competition with each other. So we have to figure out which reaction is going to occur. And based on the patterns, we can predict the likely outcome then. So here's an example. This is a secondary carbon, and we've got protic solvent. What's going to happen? Because it's protic, we're going to get an SN1 reaction. Can there be some E1? Yes, but it's usually only when there's heat involved. So you go ahead and try it on all of these. Figure out, is it SN1, SN2, E1, E1cB, or E2? For this first reaction, right here, we have a primary carbon. What's happening? We're getting substitution occurring. It's primary, so it has to be SN2. Right here, what do we have? We have a secondary halide, but we've got a base. So what must happen? E2. Here we've got tertiary halide. There's acidic conditions, so no elimination is going to occur. There's no heat, so what's happening? This is SN1. Right here, we've got a leaving group that is 2 carbons away from the carbonyl. The sodium hydroxide is removing a proton from here, and then the hydroxide leaves. This is an E1cB reaction.